Holy moly, moly, moly.
Hello, I'm Gokulan here, who representing my group members to introduce themselves. Our group consists of 4 students who will conduct lab session together with also this mini project along. Me, myself, I'm Gokulan here and followed by Kairin, Mirza and also Wong, who are my friends. We choose wire crimper as our mini project to solve some equation we did. Let me give some explanation on this wire crimper. Crimping is often used to affix a connector to the end of a cable. Wire crimpers look like a pair of pliers but join two pieces of metal or other ductile materials, such as wire to a metal plate, together. A crimper deforms one or both of the pieces, which holds them together.
Assalamualaikum. My name is Muhammad Karim Najmi and Hakim. We are also we are also the team members of this group for this mini project. So we will explain and talk a bit about the process and discussion of mini project. First of all, um, during week 13, we have done this a meeting, countless meeting during online and offline. To discuss about the distribution of workload between team members. And as you can see on the slide, the first picture is one of the pictures taken during our online meeting, which we have done on WhatsApp call. We have also made a few offline meetings in Gokulan's room in College Kediaman, Satri. After that, after we have discussed about the workload between team members, we have also done a few meetings to discuss regarding the diagram that we want to choose and how to solve the diagram. This is mostly done on online meetings, which we have done on both WhatsApp video call, and Google Meet. After that, for the free body diagram and idealized model, during our discussion, we have agreed to use AutoCAD. Initially, we have agreed to use AutoCAD in producing our model and free body diagram. But unfortunately, we have encountered a few technical issues, so we have resorted to using the manual way, which is using pencil and paper, and then we have to scan the page later. So Mirza, you can continue on your part.
Okay. Thank you, Kai. Now with the free body diagram provided by Kai, we can ease the calculation process to get the equation of equilibrium for this mini project. Now, first of all, we change the unit from pound to meter, and then we change the inch to centimeter, so we can do our calculation easier. Then we go through the analysis, which we actually try to observe, or in this project we try to calculate on when the wire crimper is squeezed. We want to determine the force applied on each jaw, and then we use the free body diagram to actually calculate the force exerted by the crimper by analyzing the equilibrium force. Then we also calculate the resultant force that shown in point A from the diagram provided. Then from there we also try to find out where the x-axis and the y-axis within the free body diagram provided. And thus we can actually gain actual calculation for this mini project. Well, that's it. I can share that about our own analysis on this project. Okay, thank you.
We will proceed to the conclusion by Wong.
My name is Wong Jahong, and I will be the member of our group to explain the mini project conclusion. After a few meetings that have been due by our group, the conclusion we choose is the crimping tool is used to crimp the end of the wire E with a force of 20 IB is applied to the handles, determine the average shear stress in the pin at A. The pin is subjected to double shear and has a diameter of 0.2 inch. Only a vertical force is exerted on the wire. That is all we have to do our conclusion calculation, and here is the calculation. And then I will explain in the Word file. Okay. At first, I will simply talk about the movement. Well, for this crimping tool, only the movement will do by the lower part of this crimping tool, which is here and have the ABD symbol. Okay, let's begin. The support reaction. From the FVDA, which is the part of the handle and the metal near the handle, we will do the calculation from two aspects, which is the horizontal force and the vertical force. Since only the vertical force will exerted, so the horizontal force always 0 from here to here. Okay. Fx is 0, then Bx is 0. Then calculate the vertical force, which is the answer will be By equal to 1130.3 Newton. Then the part we use to cut the pin, if FVDB, the horizontal force is still 0 and the vertical force after calculation is 2617.5 Newton. Then we go to the average shear stress, which pin A is subjected to the double shear. Hence, VA is equal to 308.75 Newton, and the tau is 6665.4 Newton per centimeter square, or 66,654 kilopascal. And then this is the forces that apply on the pin to cut. Okay, and all the data unit already changed to Newton and centimeter. Since the diagram is inch, and we change to this for a more simple calculation. Okay, and the calculation will be pasted on the slide. That's all.